I'm recording, so let's just go through very quickly a couple of things. So, I've given you a blank piece of paper because you're going to do something on a blank piece of paper in a minute, neatly, so don't worry about it just yet. But what we've done, just to review, those that are not here with us, we've learned how to do a 90-degree angle. What is that called? Constructing a
90-degree angle.
Perpendicular bisector. Okay, and then from that we have been able to create a 45-degree angle by bisecting the angle. Okay? With bisecting the angle. So just to go through very quickly then. So if we draw a line, I've got 2 points either end, I call them A and B. I open my compass up more than halfway, do my arc, do my other arc, go on the other end, keep it the same, arc, other arc. Okay, remember doing this. So obviously mine's really bad, but I can draw my 90-degree angle. Okay, so that's my 90-degree angle. So then, to get my 45-degree angle, I need to cut that in half. So change the colour. This then becomes the corner of my angle. So I put my compass at that point. I go arc, arc, okay? I then put my compass on, open it up over halfway, arc, put it on this side, put another arc, then this becomes the 45 degrees. Okay? If I do it again, I will get half of 45 degrees.
Mr. Potts, is that 45 degrees right there?
I just made it up. I've not used the compass.
Liam.
It might
It's meant to be 45 degrees.
Guys.
It is.
Whoa.
Liam, Steph, stop. Okay. What I asked then was, how about constructing a different angle? So I asked for 60 degrees and then 30 degrees. Now, for 60 degrees, what we need to do is we need to learn how to construct an equilateral triangle. And why does that give me 60 degrees?
Because the equilateral triangle, the sides are 60 degrees.
Yeah, all sides are
60
the same and all angles are the same. So an equilateral triangle, if I construct an equilateral triangle, I will get an angle of 60. Now it's very important that you do realise that all the sides are the same length, and that's what we use. So this is the method, if you'd like to follow me through now. You are going to draw a line anywhere on your page. Okay? No, not in your plain paper yet. Just in your book. Use your ruler, straight line. It doesn't matter how long it is. Okay? It doesn't matter how long it is. What it does matter though, okay, is that we can open up our compass to be the length of that line. If you've done your line a bit longer than that, what you then need to do is open up your compass and mark a point on that line that you can reach on your compass. But if you've done your line so that it's short enough, you can open your compass up so that the point is at one end and the pencil is exactly the length of the line. So it's open up to that length of line. So now that compass will give me all points that are the same length as that line. So what we can do, put your point at this end and arc. Okay, you can arc up and round. Then what you do, I'm sure you know already, is put your point on the other end, so your pencil's at this end, and arc up and round. Now this point, because of what we know, so from here to here, must be the same length as that line, and from here to here is also the same length as that first line. I mean, that's not bad. Look at I'm guessing on the screen, looking at an angle, and it's not too bad. Now, what I said though was I wanted a 60-degree angle, so we don't actually have to have that second line. Alright? So we can just draw two of the lines, and I do now have my 60-degree angle drawn. Okay? Does that make sense? So, you can now bisect that angle to give you 30 degrees. So just to run through it then, point here, put a little arc there, put my point over here, that will allow me to have an arc like that, point here, arc like that, and I can cut it through and bisect that. Okay?
And then we have to construct something else.
So you are going to draw a circle. So,
Oh, it hurts.
but what you must do is know where the centre of your circle is. Don't change your compass. Okay. Keep your compass the same distance. Okay. Now, why then? What have you done your circle?
No.
Right. What I want you to do now, I know what you're doing, is you are going to make a mark anywhere on the circumference of your circle. Doesn't matter where. Don't need to do it with your compass, just with your pencil. Okay, now your compass needs to be still set to the same distance that it was when you drew your circle. If it's not, then what you need to do is put it back in the centre of your circle and open it up so it's the right distance. Okay, what you are then going to do is the following. You are going to put your compass point on the point that you've just drawn. Okay? And then you're going to use it to make another mark on the circle. And then you are going to move the point to that mark, and you're going to keep going until you've done all the way around the circle. So what you do, put the point here, you'll draw the next point. Then you move your compass around and put the point on the new mark, and draw another one on the circumference of the circle. Then move your compass round, point on that one, draw another arc, and so on.
You're never going to get there.
Okay?
Draw a circle.
Then you do it again. Right? And again. Yeah. So, now what you're going to do is this. You are going to construct, well, not construct, you're going to draw a line between all of your points.
It's a hexagon. It's not even hexagon properly. Or it's like that. It's a hexagon.
Okay?
It's supposed to be a circle.
So, you'll say, yeah, we have a hexagon.
Yeah, we have a hexagon.
And what we should be able to do as well is, if it is a hexagon, we can draw our diagonals, and we end up with
Triangles. Trapezoid.
What?
triangles.
Wow. Where is that trapezoid from?
If you cut a hexagon,
Well, we didn't cut it in half.
You should have joined on the circle. Point on the circle, otherwise you just have random points, the length of your arm. Okay. My question to you is, mathematically minded people, have you drawn a perfectly regular hexagon?
No. I'm not finished.
Let's got nothing to do with human error. That's not what I want.
Compass error. Compass error.
Okay, so if we've got no problem with it, my compass slipping or my pencil being like that, guys, are you paying attention to this? All right. So those of you that like a map, okay. The question is this a perfect regular hexagon? It is a hexagon, right?
Yeah.
Because it's six-sided. Nash, are you paying attention?
Yeah.
Are you? What am I saying?
You're saying if you drawn a regular hexagon.
Hexagon.
Well, I'm asking.
Oh.
Now, do you remember, Steph, the equation for the circumference of a circle? What is it then?
Radius times pi.
So the circumference of the circle, okay, is equal to, it's actually
Diameter.
the diameter times pi. Now what do we know, or what?
Couldn't it also be the radius times 2 pi?
Yeah, or 2 times the radius times pi. Now, here's the thing. What is pi? Do you know what number pi is? Cameron?
1415.
Okay. Now, so what we've said is that the circumference of the circle, alright, is, well, if I change it to 2 times the radius times pi, okay, and we've got 6 sides. Now, does that fit? Does that work? So, for instance, this line that we measured using my compass is the radius of the circle. Okay. So the question I'm asking you is, are all of these exactly the radius? What would you do? I'd like to think why, potentially. If you've got an answer, come and ask me. So what I'm saying is, are they, all of these outside ones, definitely the radius?
Yeah.
Steph, you think yes?
Yes.
Think yes?
If
do you?
Stefan says yes, then it's yes. I can explain.
Go on, Ness.
So I think that they're all equal because
Steph, stop making little comments as you're trying to explain. Now that's on my video.
because those could be equal lateral triangles, and then
But are they? Is what I'm asking. When you constructed them, are they?
they are.
Yeah?
Yes.
Yes, and I know why it like I can prove that it's the radius and not the
Oh, we know it's the radius. That's definitely the radius. But what about all the outside ones? Are they definitely all of
Yeah.
them?
Yes.
Are all of them definitely the radius?
Well, if you don't know human error.
Did you construct all of them?
yes.
So I put my point here. Yeah? I constructed that one definitely with the compass, yeah? I then put my point there and constructed this one. I then constructed this one.
Oh yeah.
I constructed this one. I constructed that one. Cameron?
Okay, so I say yes because you had the same length of the compass.
Yeah.
From the center to there, to the side, which is the radius, and you put it from one point to the other, so that would still be the exact same distance.
Yeah. But is there a side we didn't do?
Yeah.
We didn't actually do this one.
Yeah.
Is that one? Spot on.
Yes.
I don't want it now. Have a think about it. Let me know what you think.
Okay.
Yeah.
It's the reason the radius